So in the previous 4 videos to this, we talked about D, then A, then the constant B, then C, and C also in conjunction with B. So we've got a lot to unpack there, and I strongly recommend if you haven't watched those videos before this, you should get back to that. Double check that you understand all of those individually before trying to apply them simultaneously. So what we're going to do is we're going to consider this function. And if we look at that argument, if I factor a b out, I could rewrite my argument to look like this: b times x minus some c over b. So this is kind of my phase shift form. And it may make more sense to you to think about it as multiplying that b back through to make it look like the original function. Sometimes this is hard for students to see. Anyhow, we have a function here, a sine function. We have an a, a b, a c, and a d value. We're going to list all the characteristics: the amplitude, the period, the phase shift, the vertical translation, and then we're going to pull it together and sketch the fantastic graph. Alrighty, so first thing I'm going to do is I'm going to list my pieces. I have that a is 3, b is 2, C would be listed as negative pi over 2. And remember, our standard form has a minus in front of C. So whatever the C value is that we pull out, it's always the opposite. And then giving myself a little space, I'm going to say that D is positive 1. So what is the amplitude? Remember, amplitude, amplitude's always the absolute value of A. It's already positive. My amplitude here is 3. Period. The period's the absolute value of our normal sine period, which is 2 pi. Tangent would be 1 pi. So 2 pi divided by b. In this case, 2 pi divided by 2, that's going to give me a positive pi. Amplitude and period, remember, those are always positive values. My phase shift here is the ratio of C over B. So my phase shift has a direction, and that's determined by the sign of either the C and or the B combined. So this one doesn't have an absolute value. Noting that the C is signed, I pulled that out as the opposite of what it was in there. My phase shift, negative pi over 2 divided by 2, that is going to give me negative pi over 4. So the phase shift is pi over 4 units left. We're going to be shifting left pi over 4 units. And the vertical shift is going to be up 1. So we have key points for a sine function. We know our 5 key points, right? I'm going to list them horizontally here. We have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi 0. All right, so B and C are inside with X, they affect X. 3 and 1 are outside, they're going to affect Y. So the way I'm going to determine my transformed ordered pair, my X value, whatever my X is, I'm going to divide it by 2, divide it by B, and then I'm going to subtract my phase shift. So we're going to shift left pi over 4 units. So we shrink the period, and then we shift left. My Y value, I'm going to multiply my Y value by 3, and then I'm going to add 1 to that. So if you can set up your new ordered pair, it's really very easy to take these 5 key points and to plug each of them in and transform them to create your new graph. So 0, I'm going to look at each point individually, each x and each y. 0 divided by 2 is 0, minus pi over 4 is negative pi over 4. 0 times 3 is 0 plus 1 is positive 1. So there's my first new point. Pi over 2 divided by 2 is pi over 4. Subtract pi over 4. I have 0. 1 times 3 plus 1 is 4. Pi divided by 2 is pi over 2. Pi over 2 take away pi over 4 is pi over 4. So I have pi over 4. And 3 times 0 plus 1 is 1. 3 pi over 2 divided by 2 is 3 pi over 4. 3 pi over 4 minus 1 pi over 4 is 2 pi over 4, which reduces to pi over 2. So I have pi over 2. Negative 1 times 3 is negative 3, plus 1, negative 2. And lastly, 2 pi divided by 2 is pi. Pi minus pi over 4 gives me 3 pi over 4. 3 times 0 is 0 plus 1 gives us 1. So if I were to create my new graph and we think about scaling our axes thoughtfully. So my y values are going from positive 4 to negative 2. So I can just count by ones. That's reasonable. I've got positive 4 minus 2. All right, and so my x's, I'm going from negative pi over 4 to 3 pi over 4. I have a period, the distance between my start and finish is pi. That should make sense. That's my period I have up here. So I'm going to count by pi over 4s. I see a lot of those. So I've got negative pi over 4. I've got 1 pi over 4. 2 pi over 4s, pi over 2. 3 pi over 4. I've listed those there. My 0, I didn't draw that on here. I've got positive 4 and negative 2. And then, of course, my origin is 0. So negative pi over 4 up 1. 0 up 4. Pi over 4 up 1. Pi over 2 down 2. And 3 pi over 4 up 1. So really, my sine graph, it just looks like a regular sine graph. Nothing looks different. But my axes are different. My axes are scaled thoughtfully. All right, so when you're drawing these on your own, you don't have to draw that regular sine function on there. Just think about what your points are and recreate them. So I hope that kind of helps you to understand all of these trig transformations together. As always, reach out if you have any questions. And if you're enjoying this series, don't forget to like and subscribe.